Now that we have the data, let's start analyzing. First, we are going to calculate the descriptive statistics. Go to Analyze Descriptive Statistics and Descriptives. Select variables you want to explore. Check the Options button if you want additional statistics. And press OK. The output will appear in the statistics viewer as a table. Now let's do one-way ANOVA. We are interested in determining whether satisfaction levels differ between region groups. Compare means and proportions. One-way ANOVA. Set satisfaction as dependent variable and region as the factor. If multiple comparisons are needed, click Post Hoc Tests. I'm gonna do Bonferroni and Tukey. Press Continue and OK. From the output table, the p-value is 0.132, which is greater than 0.05. We also have 95% confidence intervals, but they all include 0, indicating no significant differences among each region groups. Thus, our conclusion can be satisfaction levels do not significantly differ based on region. We also get the effect size, but that one also has 0 included. Now let's fit a simple linear regression model to check if age and hours online impact income. Click Analyze Regression Linear. Set income as the dependent variable and age and hours online as the independent variables. To check assumptions, click Plots for Residual Diagnosis. Produce all partial plots and histograms and QQ-plot. And you can press Statistics to do a collinearity diagnostic to access multicollinearity. The R-squared is 0.585, indicating a moderate modal fit. You can see that the VIF is approximately 1.5, indicating no multicollinearity issues. And we have all the histograms for dependent variables and QQ-plot as well to check the normality of our dependent variables. And the partial regression plots are for the residual diagnostics. And from the coefficients table, only age is significant because the p-value is 0.029, which is less than 0.05. What if we want to include an interaction term between age and hours of online? Then you need to calculate the variable. Go to Transform Compute Variables, name the new variable, and define the numerical expression as following. Press OK. Now include this new interaction term in the regression model. Adding the interaction term causes multicollinearity issues in this case, as the VIF values exceed 10. Which was pretty obvious because the previous model had only age as significant variable. And here are the following are partial regression plots for residual diagnostics. Now let's check normality assumptions. We can verify the normality of variables using both plots and statistical tests. Go to Analyze, Descriptive Statistics, and Explore. Add the variable you want to check into the dependent list. Under Plots, ensure normality plots with tests is selected. From the Shapiro-Wilks test, the p-values are greater than 0.05, indicating the variables follow a normal distribution. You can look at the SIG column. And we can also check the normality based on the histograms, QQ plots, and also box plots. Since the normality assumptions are met, we can now do a two-sample independent t-test. Let's test if the average income differs between gender groups, male versus female. Go to Analyze, Compare Means and Proportions, Independent Samples t-tests. Set income as the test variable and gender as the grouping variable. Click Define Group and input 1 for male and 2 for female. Press Continue. From the table, Levine's test for equality variances gives a p-value of 0.832, indicating equal variances are assumed. So you can look at the first row. If it is not met, you can look at the second row. The t-test p-value is 0.007, which is less than 0.05, and the 95% confidence interval confirms a significant difference. Thus, males have a significantly higher average income, and the mean differences is between 653 and 3,354. If normality assumptions are not met due to small sample sizes, we use the Mann-Whitney U test instead of the t-test. Go to Analyze, Non-parametric test, Legacy dialogues, 2 independent samples. Set income as the test variable and gender as the grouping variable. Click Define Groups and input 1 for male and 2 for female. Ensure Mann-Whitney U is selected and press OK. The asymptotic p-value is 0.015, which is less than 0.05. So the conclusion is Mann-Whitney U test also confirms that income significantly differs between gender groups. Now let's save our SPSS outputs. To save your output, go to File, Save As, to save the file in SPV format. You can reopen this file later to modify or continue your analysis. To export the output to a Word document, go to File, Export, and press OK. You can change the file name if you want. The SPSS outputs will now appear in your Word document.